Hello, George. I hope this video finds you well, and I also hope it serves you well and answers all of your questions. So let's get started with question one that I have for you. It may be a little bit of a recap. I think it's important that I go over some of these concepts before we get to the slightly tougher problems. So just if you already understand how to do these very simple quadratics, you can skip over this part and go to question two, but if not, here we go. So the first thing you want to do is identify your A, B, and your C. So in question one, our A is equal to 1, and our B, I'll explain where these numbers come from in a moment, is -4, and our C is -45. So here for the A, it is the coefficient of the x squared term, which there is a hidden 1 here. Obviously, there's a 1 there in front of the x, so that's why A is equal to 1. B is equal to -4 because that is the number that comes before the x, and it's important to not forget this negative sign here. And same is true for C, except C is a constant. There is no variable in the constant. There's just no variable, so you just take the number back up like this. So now that we've identified our A, our B, and our C, I saw in your paper that you have that x thing, and that's a very good way to learn how to factor. So I'll use that for a simple problem like this. The top is going to be A times C, and the bottom is going to be B. So instead of writing these variables, I'll obviously replace them with the actual number. So we have 1 times -45, which is just obviously -45. And in the bottom, we just put B, which is -4. And now our problem is we need to find two numbers that when we multiply them, right, we get -45, but also when we add them, we get -4. So what two numbers immediately come to mind? 9 and 5. Those sound like numbers that will work because 9 times 5 is 45, and 9 and 4, the difference is 4. So it seems like those two numbers will work. So it's just a matter of finding the right sign. So 9 times 5 is +45, so we know that one of these has to be negative. And let's say that we made the negative and make it a -5. Well, 9 times -5 is -45, but 9 plus -5 is not -4. It's +4. So it's important to make sure you don't mess up those signs there. And so -9 times 5 is -45, and -9 plus 5 is -4. So that means that we are good and we have our two factors and we can continue. So now that we have our two factors, we can rewrite this expression right here. Equation. We can rewrite this as x minus 9, and we're just taking this term and putting it here, times x plus 5. And because these two equations are equal to each other, we can set them both equal to 0 because the first one's equal to 0 and the second one must be because they're equal. So now we use what's called the zero factor theorem, which says if this term is equal to 0, then this whole statement is equal to 0, and the same is true for the other one. So that means we have two solutions for x, and in the problem that we have as the example, we can say x minus 9, if that's equal to 0, that does satisfy our equation. So we add 9 to both sides, and that means that x equals 9 is one of our solutions. And we can do the same for the other one. X plus 5 equals 0, subtract 5 from both sides, and x equals -5 is our other solution. And of course, you can always check this by plugging these numbers, replacing them wherever you see x in the original equation. And if the number gives you 0 when you plug both your solutions in, then you know you did something right. So that is hopefully a little bit of a warm-up before we get to the next problem. And you'll notice immediately that the biggest difference between problem 1 and problem 2 is the A is different. The coefficient of x squared is not 1. So what do we do? Well, we can still use the x method, but the question you asked me was about why we factor out the 5. So I'm going to show you how to do it that way, but if you like some further clarification on how to use the x method, I think you already know how to do it because I saw it on your paper, but again, if you need some further clarification, I'm happy to give that for you. So let's start with this problem by identifying our A, which is 5, our B, which is -35, and our C, which is 60. And I also just want to say before I start this problem that there are many ways to get to the correct answer, but the ones you're learning about are the simplest and just the easiest, straightforward way of getting the numbers. So there are multiple different ways of factoring this. There's even equations that we've developed for this, like the quadratic formula. So, or formulas, not equations. We've found a lot of formulas for these things. So just remember that this isn't the only way to do things, but it's definitely the easiest when you're working with nice, clean numbers like this. So let's go forward with the problem. So I'm just going to rewrite what we have here, 5x squared minus 35x plus 60. So, and that's equal to 0. So what can we do to this equation to make it easier on ourselves? Well, immediately I see that all three of these terms are factorable, or 5 is a factor of all three of these terms. So what we can do is we can say 5, open parentheses, and what do we have to do? What do we have to multiply 5 by to get 5x squared? Well, pretty straightforward. We just have to multiply by x squared. And when we end up distributing here, this will turn into 5x squared. So we're not changing anything about the first term. It's the same way. It's written the exact same, or excuse me, it's not written the exact same, but they have equivalent value. And now we're going to do the b. So negative 35x. What do we have to multiply 5 times to get negative 35x? Answer is minus 7x, right? Because 5 times negative 7x is negative 35x. And now finally we do our c. And what number do we have to multiply 5 times to get positive 60? The answer is plus 12. And when we multiply this, we get positive 60. And we can set this equal to 0 because these two equations are the same. All we're doing is taking out the 5. So I'm going to go up here just for a second and rewrite what we found. So we have 5 times x squared minus 7x plus 12 is equal to 0. And going back to very basic algebra, what you do to one side, you must do to the other. So because we're multiplying this entire term by 5, remember when we distribute and we multiply all of this side by 5, we're still going to come back to the original equation. So and so that's fine. And we can move forward by, sorry, I lost my train of thought, but I'm refocused now. So because we have this 5 here and we're multiplying it by all of these, we can actually we can divide the 5 on both sides. Because what we do to one side, we must do to the other to keep the. So now if we divide both sides by 5, well, 5 times x squared minus 7x plus 12, when we divide that by 5, we're just going to get x squared minus 7x plus 12 equals, and 0 divided by 5, well, 0 divided by anything is just 0. Now, of course, if there was a 0 on the bottom, we'd have undefined. That wouldn't happen. But in this case, we just get 0, and that's what's beautiful about the zero factor theorem is we can get answers really, really easily when we set our equation equal to 0. And now, after factoring out the 5, we can see that we have an a equal to 1. Our a is equal to 1, right? And that's kind of what your teacher wants to show you, is that it's going to be easier if you get your a to 1 because it's just much easier numbers to work with. But like I said, there are many ways to solve this problem, including the x method, which I think you already know how to do. So let's just label our parts here. We have b is equal to negative 7 and c is equal to 12. So we can now do the x method like so. And in the top we have a times c, which is 12, and we're going to multiply. Here we're going to add, and we have negative 7. So what two numbers together, when you multiply them, give you 12, but also give you 7 when you add them? Immediately 4 and 3 come to the top of my head just because, 4 times 3 is 12, and 4 plus 3 is 7. So that seems like it's going to work out. So let's try it. And sometimes it's not gonna come so easy finding that number or finding these factors that work. So you always want to just, if you're lost, just list all of the factors of the top number, and you really should be okay because these are the only possible answers that would satisfy this. And obviously we can see 3 and 4 are are the ones that are going to make it work. So 4 times 3, that's positive 12, but 4 plus 3 is not negative 7, it's positive 7. So if we remember that negative times negative is also a positive, we can make both of these negative. Negative 4 times negative 3 is positive 12, and negative 4 plus negative 3 is negative 7. So now we have our two factors. I'm going to come back over here just because I'm running out of space a little bit. So sorry if it's a little all over the place, but we can then write this as x minus 4 times x minus 3 is equal to 0. And now we can just use the zero factor theorem to get to our answer. So x minus 4 is equal to 0, and x minus 3 is equal to 0. Add 4 and add 3 to both sides, and we get x is equal to 4 and x is equal to 3. So that is how you solve this problem using the method that you wanted me to explain. But again, you don't have to factor out the 5 to do this x method. You can still do it that way. And I think I did see that on your paper, so I'm going to skip it. But again, if you have questions about that, I am more than happy to make another video for you. Now, the last one is going to be a curveball. And I'm not sure if you are familiar with the quadratic formula, but in case you're not, the quadratic formula goes as follows. Negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And you're like, what are these variables? Well, they're just the numbers from our original equation. So we have a is equal to 20, b is equal to negative 9, and c is equal to 2. And it's worth mentioning before we solve using the quadratic formula that this is not factorable. So first of all, we can't take out 20 from 19 or 2. That they're just not, 20 is not a factor of 2. So there's no way to proceed like we did in number 2. And the x method doesn't work either, because if we do a times c, we're going to get 40, and in the bottom we're going to get negative 19. And there are no numbers that are going to easily factor, they're just not going to factor with whole numbers. So we do have to use the quadratic formula. So let's continue. Let's just substitute everywhere we see A, B, and C. We're just going to substitute the values that we have. So let's rewrite this as negative. And then remember, you do not want to forget that this is negative 19, not positive 19. And just because it starts with a negative does not mean you omit or you forget this other negative from the B. Plus or minus, and that's very important. I want to pause because this is a huge part of mathematics. Whenever you take the square root of something, it's plus or minus. So the reason is because let's say we take square root of 4. Well, that's pretty easy. That's just 2 times 2, right? So the answer is just 2, right? Well, actually, the answer is also negative 2, because negative 2 times negative 2 gives you a positive 4. So whenever you take the square root of something, you must say plus or minus, and that is a very important part of the quadratic formula to remember. So let's go back to our problem. Negative 19 plus or minus the square root of b squared, which is negative 19 squared, minus 4 times 20 times 2. We're going to divide everything by 2 times 20, right? Because our a is 20. And now we actually have something to work with to find our solution. So it's very, very ugly, I know, and there's a lot of room for mess up. But if you remain focused, you do the work, you practice, I promise you, you will not mess this up. I of course mess it up sometimes, but that's human error. But it's not as complicated as it looks, is what I'm trying to say. So negative 19 times a negative 1 is just positive 19. Remember, there's just a hidden 1 here. And we have positive 19 plus or minus the square root of negative 19 squared. Well, negative times negative is positive, and 19 squared is 361. And we're going to take away negative 4 times 20 is negative 80. And then times 2 is negative 60. So we'll write this as 361 minus, this is negative 160. I mean, you also could have just kept the minus here and multiplied 4 times 20 and 4 times 2, which would give you 160. And if you kept the minus, brought it down, you also would get minus 160 here. And again, the bottom is all divided by 2 times 20, which is 40. And we can simplify what's inside of the radical by saying 361 minus 160. Let's see, what is that? That is 201. And actually, this is our final answer. It can be expressed two ways. This is correct, but also you might want to write it as this. So x is equal to 19 plus or minus the square root of 201 divided by 40. Oh, not, excuse me, I'm not saying, excuse me, not plus or minus, just plus for this one over 40. And the other answer is x equals 19 minus 201, square root of 201 over 40. And remember, that's just this plus or minus coming in to give us two answers. And like I said, whenever you take the square root, you will have two answers. So these are the two answers to the problem that I gave for you as some further context. Again, if you don't know how to do the quadratic formula or haven't learned it yet, no big deal, but it is very important for what you're doing. So, and just to show you that this is correct, I'm gonna pull up mathway.com and plug in the original problem, 20x squared. 20x squared minus 19x plus 2 is equal to 0. And if we say, see, solve using the quadratic formula, that's very important because you can't solve by factoring. Look, if we solve by factoring, I mean, we did get the answer, but we had to use the quadratic formula. I don't know why it's showing you like that, but you can't factor this. You have to solve using the quadratic formula. And as you can see, these are our two answers for x, which match up with the two we got. So just to kind of recap, the first problem should be nothing new to you, but I just wanted to introduce and remind you of the zero factor theorem. Now the problem changes when we have a different a value, but again, we just factor it out if possible. And if it's not factorable, there are other ways to proceed, which I'm happy to make a video on and show you. Or I'm sorry, if you can't factor out, like let's say that this was 6 and not 5, right? Obviously, we can't take 5 out of all of the terms. So if this was 6, I mean, 6 doesn't go into negative 30. It doesn't go into 35. It goes into 60, but it doesn't go into 35. So we can't do this way. We have to use another method, which could be the x method. Like I said, you could just use a times c, and there's another way to proceed. I'm happy to show you that at another time if you need help with that. I saw it on your papers, so I figured maybe you know. And then I gave you a quadratic formula example so that whenever you're stuck or the numbers just aren't making sense, you can always count on this formula. And I'm going to end with a little jingle I learned when I first learned this, and maybe it will help you remember it. So it's like Pop Goes the Weasel. You say, negative b plus or minus the square root of b squared, take away 4ac all over 2a. That little jingle has stuck with me throughout my entire career in mathematics, and I'll never forget the formula after singing that song to myself 10 times. So I hope this has been helpful for you, George. If you have any further questions or you need some other things answered, please feel free to reach out. I'm more than happy to help you. I wish you the best of luck on your finals. I know you'll do well. And like I said, if you need more help, just please let me know. I'm happy to help you. Thank you so much, George, for watching, and I hope this has been helpful.